What's up, world? Okay, let's talk about lines. Okay, but we're not gonna get into the nitty gritty like we have before about standard form, slope intercept form, um, point slope form. We're just gonna talk about quick access to understanding the linear function. Okay, because it's important that as we move on to do higher level math, we can't be bogged down any longer in this idea, right? It's like, let's say you're learning basketball, okay? And your teacher, your coach is like, okay, so here are the rules of the game. You have to consistently dribble, right? And then plant your feet, pass. What's the object of the game? Is to put the ball in the hoop and make sure that you have more points, you and your teammates end up with more times that the ball went into the hoop than the other team. That's the goal, right? So now coach blows the whistle and everyone's starting to learn dribbling, and we're going to dribble on the right hand and we're going to dribble on the left hand, and then we're doing back to back, and we're doing this, arc shot and free throws and layups. Being stuck on a line for your mind, like the linear function, is as if you're standing on the sidelines holding the ball, and every single day at practice you go to your coach. So coach, tell me again about I have to dribble? And the coach would be like, yeah, you have to dribble. Like, you can't, right? And you can't, you can't palming the ball is again, although the NBA right now, am I right? And then like, traveling and and that maybe the first couple days the coach would be okay with that. But if after months and years you're still asking about the rules of the game, is it any wonder that you get frustrated, and so does your coach? Okay? That's being bogged down in the linear function. Just learn it. Just practice going left. Just practice the around the world behind your back. Just practice it. You can practice it on your own. You can go to the local park. You can go after school. Just practice. That's the linear function. Okay? But I want to give you an overview so that we can kind of let it go of the words. Okay? Because this is the game. This is the court. The XY coordinate plane. Okay? This is the court. This is the ball field. This is the playing field of mathematics, of higher level mathematics. It is very difficult to do higher level mathematics without comprehending the idea of the coordinate plane. You can play baseball, like you can play catch and hit a baseball on any field, correct? You're right, you can. But the demarcations are needed to really play the game. Soccer and football share a field, but they do not share the boundaries, right? This is the game of mathematics. It exists right here. Okay? So let's make sure we know what it is. First of all, there are words you will never get away from. Slope and intercept. Slope and intercept. Intercept is where it crosses the axis. You can have a y-intercept and you can have an x-intercept. Always. Okay? You can have a y-intercept, you can have an x-intercept, you can have multiple intercepts. Now, slope is very specifically linear. Slope is the line. And as you get into calculus, you're going to be looking for an instantaneous slope. Okay? And rate of change. We can get into physics and all that too. But you gotta be rock solid on this line. It literally is the rules. It is the dribbling right-handed rules of playing basketball. So, slope is measured as change in y over change in x. So, for example, I like to think of it as a runner. Here's my little runner. Well, I'll let you see my runner. My runner is running. They're running along X, and they're going this way. Okay? If they are running on a flat thing, we say the slope is 0. It's 0. Okay? If you're going downhill, running down, is it easier as a runner or harder? Well, unless your knees are destroyed like mine. No, my knees aren't destroyed. It's just, it's painful. It is easier, okay? That's what we call that is a negative slope, okay? If you are running uphill, that is a positive slope. 0, negative, positive. What is that slope? If you run into a wall and you can no longer run, how do we even define that slope? It is undefined. It is it slam you right into it slope. Now, that is where the y, the x doesn't move, and it mathematically is also impossible because it's dividing by 0. So it is without definition. Slope is defined as a hill. So if you're going uphill, it's a positive slope. If you're going downhill, it's a negative slope. If you're staying flat, it's a slope of 0. If you're perfectly vertical, it is not with definition. It is undefined. So if you want to think of this as a little rotation, you go positive, 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 0, negative, 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 undefined, positive, 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 0. It's like a clock. It just keeps going around. Okay? If you can help get that through, then you can make quick decisions on if your graph matches your equation. If you did it right, okay? This understanding is like noticing that your ball went into the hoop or not. Do I count the points? If you just thought that scoring the basket meant you had to hit the rim, then you have then that's a fundamental misunderstanding, right? It's got to go in. So when you put this in your brain, you are now understanding the whole game a little bit better. Are you picking up what I'm putting down? Okay, so now let's talk about intercept. This is 0 because what do we call this? We call this the origin. This is where we get words like original. This comes from the constellation Pulled myself out there for a second. So here is what we want. So we go up. Now I've got an intercept of, what is that spot? 1. We go down, the intercept of -1. That's the y-intercept, okay? This is how we build equations quickly. So when you have y equals 2x minus 3, y equals 2x minus 3, okay? I'm not going to plot out points. I'm not going to do this the slow way. Oh, there's my lamp. Hi, lamp. Do you like it? I was about to make a Seinfeld joke. Okay, so now we can quickly see. We go, okay, this is positive, so we're running uphill, and this is -3. So I can go down here, 1, 2, 3, because that's down is negative, right? And I go, well, it's going to be about like that. It's going to be about like that. Boom. There's my line. Thereabouts. And I know that because I understand how to interpret this sentence. This shows me that it's a slope above 2. This shows me that I'm dropping down to -3. Now, as you move on in math, you're going to have to understand these things. But slope and intercept never go away. And in fact, in calculus, when you are regularly, differentiation is regularly trying to understand the immediate slope, right? What is happening right now? What is the projection right now? If we want to go back in time to think about COVID, do you remember the phrase in COVID that people were saying, flatten the curve? It's because we were in real time wanting to make COVID growth stop. It wasn't that COVID cases weren't going to come on anymore. It wasn't that there weren't going to be people that still had COVID. It was going to not grow on a day-to-day basis. Not grow. Okay? Don't get me started about how people manipulate and lie with data. But that's when people said flatten the curve. Do you remember that phrase? Flatten the curve. That's what they're talking about. The curve is was a graph of COVID cases. The flattening was getting the slope to be 0 so that it would diminish. Slope being 0 didn't mean there weren't any more COVID cases. It only meant that it wasn't growing instantaneously anymore. That is why everyone was obsessed, and scientists and politicians were saying flatten the curve, flatten the curve, flatten the curve. Because in that particular moment in our lives, it was growing at an exponential rate and we were trying to mitigate it. It was a fascinating time to be a mathematician. I don't want to say I loved it because COVID was weird, but it was fascinating. So I want to revisit that because that is the perfect example in real time. And if you can't take mathematics away from COVID, please do, because that is the purpose of math. We all lived it together, is to take numbers, is to take projections, and then to analyze it and then try to respond to it. Personally, for me, I live I get to be a part of big governmental budgets sometime. And I want to say sometimes if we want to mitigate these issues, we got to do ABC with the budget, with the monetary, right? Because budget's just energy. That's math. That is the purpose of math. Mathematics is about comprehending the whole world so that we can make predictive measures and we can interact with each other in such a way. So that's my high view, desmos.com. Please don't forget it. It's a great tool. I wish it existed when I was your age, whatever age you are. And it exists now, and I use it a lot. It's useful. If you can subscribe, if you've watched it this far, I appreciate you. It would just really help me get the word out. I'm trying to give away math for free, just because I know the world needs it. Until next time, friends, I'll see you later.